Okay, so because at the equator is warmer than the air at the poles, it's less dense. So if you could imagine a non-spinning globe, like this picture here, because the air at the equator is less dense, it rises, and then the cold air will sink at the poles. So this process sets up a large circulation cell. You can see that in the white arrows, with the air rising at the equator because it's warmer there and flowing in the high atmosphere to the poles and then sinking and flowing at low levels back to the equator. This flow represents the root cause of all wind. So this is kind of an idealized system, but this is how that would go. So the real world's a little bit more complicated. For reasons having mostly to do with the depths of the atmosphere and the heat differential between the poles and the equator, 3 circulation cells have been understood between the equator and each pole. Okay, so you can have the 0 degrees, that's the equator. You've got an up and down blue circle there in the north and in the south hemisphere, then a second one, and then a final one. So these are called Haley cells. And so as air rises at the equator and diverges, it moves both north and south. And at about a 30 degrees latitude, it starts sinking because it's gotten cold. Air also rises at the 60 degrees latitude and moves north and south, and sinks at both the 30 degree latitude and the poles. So you're going to have these ups and downs. So you have these 3-dimensional circles moving because of the uneven heating and cooling of the Earth. So let's introduce the rotation of the Earth. Okay, due to the Coriolis effect, okay, so the Earth is now moving towards the east. Okay, it's moving towards the right here. The Coriolis effect is basically like pulling the tablecloth out from under the dishes. The dishes seem to be moving left because the tablecloth is moving right. It's the same thing. The winds are going to be appearing to curve, even though the winds simply blow from high concentration to low concentration. They will flow in sphere curves. So they're arced because the Earth is not flat and it is moving at the same time. So you end up with essentially the Earth is being moved out from under the air. The air is kind of stationary, it has inertia, and so it basically stays put, the Earth moves, and the winds appear to be moving away from the moon or the Earth. Okay, so when we combine the simple convective cells, those are the Hadley cells that we were looking at, the winds going up into the atmosphere, along with the Coriolis effect, you end up with familiar wind patterns. And so you'll always anticipate the winds coming or the weather coming from the same direction. One side of your house is always more weather beaten than the other. Okay, normally the southwest is where we get all of our weather because of the turn of the Earth and the way the winds are moving. Okay, we are about 48 latitude, so we're above that top yellow line at 30 degrees north, and so the winds are moving from the southwest to the northeast, and our weather will follow those winds. In this chapter, we're looking at the ocean currents, and you'll see that the ocean currents are being moved by these winds. So when we combine our simple convective cells and the Coriolis effect, we find the trade winds at the latitudes, okay, and we find the westerlies at the mid-latitudes, and that's where we are, the prevailing westerlies. These are the winds that drive the major ocean currents, the surface currents of the ocean. So when we combine the trade winds and the westerly over the ocean with the Ekman spiral, now we'll study that in a little bit differently, we'll develop a westward flowing equatorial current. Okay, so you're going to get a current, surface current that kind of goes in a circle, and it just goes around and around and around, and I'll show you that. Okay, so the winds are moving above 30 degrees, they're moving in one direction. Below 30 degrees, they're moving in the opposite direction. So you're going to get a circle of currents in the ocean. It's absolutely brilliant how this was put together. So when these eastward flowing currents encounter a continent, they're diverted towards the equator. They move around. They can't go through a continent because they're water, so they slosh around, and then they find themselves again, and then they are a circle. Okay, so they feed the equatorial currents and close the loop, and we refer to these loops around the ocean basins as subtropical gyres. A gyre is a gyration or a circle. So let's look at these together. You'll see here that's the wind blowing with no curvature or no circle of the earth. Now the earth is moving. The winds appear to go in the opposite directions. So those are the prevailing winds in each of the latitudes. And those latitude winds will then affect the currents. So the currents, surface currents, will move around and around based upon that. So I hope this helps